Welcome to Deep Dive Podcast, Episode 3. Today we're taking a deep dive into alcohol's impact. Brain neuroscience explained. We've got a really fascinating stack of sources here that break down what actually happens, inside your head when you have a drink. Our mission, as always, is to cut through the noise, pull out the key nuggets of knowledge, and give you a shortcut to really understanding how this very common substance affects our most complex organ. So get ready for some surprising facts, maybe some aha moments as we explore the intricate world of your brain on alcohol. We'll cover everything from the immediate chemical shifts to the longer-term changes, and even, interestingly, the brain's capacity for recovery. So let's start right at the beginning. Alcohol's journey. How does it actually get into the brain in the first place? We're talking about ethanol, right?
Exactly, ethanol. And the sources describe it as a small lipophilic molecule.
Lipophilic. Sounds technical. Why is that important?
Well, lipophilic just means it likes fats or lipids. And your brain, it's actually about 60% fat.
Oh, wow. Okay.
So because ethanol likes fats, it can slip across the blood-brain barrier incredibly easily. Think of that barrier like super tight security for your brain.
Right. Keeping unwanted stuff out.
Precisely. It checks IDs, keeps things out. But ethanol, it just waltzes right through, no problem.
So it gives instant access, basically.
Pretty much. And once it's inside, it doesn't just, float around. It immediately starts interacting with different neurotransmitter systems.
Chemical messengers in the brain.
Correct. And that's where all the effects we associate with drinking actually start. It happens fast. Okay,
so let's unpack that. It's actively engaging with these messengers. It's not passive. Where does it start? I hear a lot about GABA.
Yeah, GABA's a big one. Gamma-aminobutyric acid. It's often called the brain's main brake pedal.
The brake pedal, meaning it slows things down.
Exactly. It's the primary inhibitory neurotransmitter. Its job is to calm things down, reduce nerve cell activity, keep things from getting too excitable.
Okay. And alcohol.
Alcohol enhances GABA's effects. It binds to specific spots on what are called GABA receptors.
Enhances the braking.
Right. Think of it like pressing down harder on that brake pedal. It makes it harder for neurons to fire off signals.
So what if that is?
Yeah.
Feeling relaxed, less anxious.
Precisely. That's the mechanism behind the sedative effects, the relaxation, that feeling of reduced anxiety, that initial moment some people get.
Lowered inhibitions too, I guess.
Definitely. When the brain's braking system is boosted, that internal filter or sensor we all have gets turned down a bit. People might feel more outgoing, talkative.
Interesting. So if GABA is the brake, our brain must have an accelerator too, right? What about that side of things?
Absolutely. The main accelerator is glutamate. It's the primary excitatory neurotransmitter. Its job is to get neurons fired up and sending signals.
The go signal.
Exactly. Now, alcohol does the opposite here compared to GABA. It inhibits glutamate, specifically by blocking NMDA receptors.
NMDA receptors. Those are important for learning, aren't they?
Critically important. For learning, memory formation. So when alcohol blocks those, it's like putting up roadblocks on the brain's information highway. Excitatory signals can't get through as easily.
So wait, alcohol hits the brakes harder with GABA, and it blocks the gas pedal with glutamate.
You got it. It's a double whammy, really. Increasing inhibition and decreasing excitation.
And the result of that is fuzzy thinking, memory issues.
Spot on. This directly impairs cognitive functions. Learning new things becomes harder. Memory consolidation gets disrupted. That's why conversations might seem hazy the next day, or why you struggle with problem solving.
Is this the root cause of blackouts then?
It's absolutely central to it. A blackout isn't just forgetting. It's a failure to encode the memories in the first place. The brain's recording equipment was essentially turned off for that period because of the glutamate disruption.
Wow. Okay. So GABA, glutamate. What else is alcohol messing with? I hear about dopamine quite a bit, the reward chemical.
Yes, dopamine plays a huge role. Alcohol significantly increases dopamine release, especially in a key part of the brain's reward circuit called the mesolimbic pathway.
The reward pathway.
Right, and specifically in an area called the nucleus accumbens. Think of it as the brain's pleasure hotspot.
So alcohol triggers a dopamine flood there.
It does, and that flood feels good, very good, potentially. It creates that sense of pleasure, euphoria, and reward.
Which sounds nice, but I'm guessing that's where the addictive potential comes in.
Exactly. That dopamine surge powerfully reinforces the drinking behavior. Your brain learns very quickly, alcohol equals pleasure, do that again. It hijacks the natural reward system.
So it's teaching the brain to want more.
Precisely. It drives the craving and is a key reason why alcohol can be so highly addictive for some individuals.
Okay, makes sense. What about mood? Beyond that initial dopamine hit, does serotonin get involved?
It does. Serotonin is crucial for regulating mood, sleep, appetite, lots of things. Now, short-term, acute alcohol use can actually increase serotonin levels temporarily.
Leading to that initial happy buzz, maybe.
That can be part of it, yes. That feeling of elevated mood or euphoria.
But there's a but, isn't there?
There's a big but with chronic use. Over time, persistent heavy drinking can actually lead to serotonin depletion. Levels drop.
And low serotonin is linked to.
Depression, anxiety, irritability. So while alcohol might offer a fleeting mood lift initially, long-term use can seriously disrupt mood regulation and contribute to worsening mental health issues. It becomes a vicious cycle.
Right. Drink to feel better, but it ultimately makes you feel worse.
Exactly.
Okay, so we've got these neurotransmitters, GABA, glutamate, dopamine, serotonin, all being affected. Where in the brain are these effects most pronounced? Which regions take the biggest hit?
Well, one major area is the prefrontal cortex, right at the front of your brain.
That's the CEO, right? The decision-making part.
That's the one. It handles executive functions, planning, judgment, impulse control, social behavior, personality. Alcohol significantly impairs its activity.
Which explains why people might do risky things or make poor decisions when drunk.
Absolutely. The CEO is temporarily, let's say, impaired. Judgment goes out the window, inhibitions are lowered.
And is that just temporary, or are there longer-term worries for the prefrontal cortex?
Oh, definitely long-term concerns with chronic use. Studies show structural changes, including reduced volume, actual shrinkage in the prefrontal cortex with long-term heavy drinking.
Wow, shrinkage. That sounds serious.
It is. It can lead to persistent problems with decision-making, emotional regulation, and social interaction, even when sober.
Okay. Where else? You mentioned memory issues earlier. That points to the hippocampus, doesn't it?
Correct. The hippocampus is vital for forming new memories. It's like the brain's save button. Alcohol disrupts this process significantly.
Hence the memory lapses and blackouts we talked about.
Exactly. And again, with long-term use, there's a risk of hippocampal atrophy shrinkage of this memory center.
Which would mean ongoing memory problems.
Yes, worsening cognitive deficits, difficulty learning new information, problems recalling recent events.
And what about coordination? The stumbling, the slurred speech, where does that come from?
That's primarily the cerebellum. It
Yep.
sits at the back of the brain, underneath the main cerebrum.
The balance center?
Precisely. It controls motor function, coordination, balance, posture, even fine motor skills needed for clear speech. Alcohol hits the cerebellum hard.
So that's why people sway, slur their words, have trouble walking a straight line.
Absolutely. Those are direct signs of cerebellar impairment. And, like the other regions, chronic heavy alcohol use can cause cerebellar degeneration.
Leading to lasting coordination problems.
Yes, persistent issues with balance, gait, tremors, sometimes even after stopping drinking.
Okay, so we've mapped the how and the where. Let's talk about the when. What's the difference between the immediate short-term impacts and the really serious long-term consequences?
Well, the short-term effects are pretty clear, right? We've touched on most of them. You got the impaired thinking, reduced attention, memory gaps, bad decisions.
Then the motor problems, slurred speech, unsteady walk, slower reactions. Very dangerous if driving, for instance.
Crucially dangerous.
Emotional swings to euphoria, maybe aggression, sadness, and of course those blackouts, chunks of time just gone.
Amnesia for events that occurred while intoxicated.
Right, those are the immediate consequences. But what happens when drinking isn't just occasional, when it becomes chronic, heavy use over time?
That's when we see the really profound, often long-lasting damage. We're talking about neurodegeneration, the actual damage and death of brain cells.
That leads to the brain shrinkage you mentioned.
Exactly, measurable brain atrophy, especially in those vulnerable areas like the frontal lobes and the cerebellum. This isn't just temporary impairment, it's physical damage.
And that translates to
Significant long-term cognitive decline, persistent problems with memory, attention, planning, problem solving. Things don't just bounce back easily after years of heavy use.
Are there specific conditions linked to this long-term damage?
Yes. One severe one is Wernicke-Korsakoff syndrome. It's a serious neurological disorder caused by a thiamine deficiency, which is common in chronic alcoholism because alcohol interferes with nutrient absorption.
What does that look like?
Severe memory loss, like profound amnesia confusion, problems with coordination, It's debilitating.
And the link to dementia, is that established?
Yes, the link is quite strong. Heavy, prolonged alcohol use is a known risk factor for developing various types of dementia, including what's sometimes called alcohol-related dementia, and it can also contribute to the risk or progression of Alzheimer's disease.
That's incredibly sobering to think about the potential long-term toll. But amidst all this, well, frankly, quite concerning information, there's also research on recovery, isn't there? The brain isn't just passively taking damage, it has resilience.
Absolutely, and this is a really important message. The brain has remarkable neuroplasticity, its ability to adapt, reorganize, and even heal itself.
So even after prolonged heavy drinking, if someone stops, the brain can recover.
It can show significant signs of recovery, yes. Structurally, studies show that abstinence can lead to a partial reversal of that brain shrinkage we talked about. Brain volume can increase again, which is quite amazing.
Volume can increase, so the brain can actually regain some lost ground.
It appears so, yes. And functionally, too. Cognitive functions like memory, attention, executive function, they can improve, sometimes substantially, with sustained sobriety.
How does that happen? The brain rewiring itself.
Essentially, yes. Forming new connections, strengthening existing ones, and there's even some evidence suggesting neurogenesis, the birth of new neurons, might occur, especially in the hippocampus, with abstinence.
Wow, new neurons. That's incredible. So there really is potential for healing.
There absolutely is. It's a powerful testament to the brain's resilience. But it's important to add a nuance here.
Right.
The extent of recovery really varies from person to person. It depends on many factors: how long and how heavily someone drank, their age, their overall health, genetics, other conditions.
So recovery is possible, often significant, but not always complete or the same for everyone.
Exactly. But the key message is that positive change is possible with abstinence and support. The brain can heal.
Okay, so we've covered a lot of ground today. From how alcohol, that simple ethanol molecule, gets into the brain so easily,
Crossing that barrier.
to how it interacts with key chemicals like GABA, glutamate, dopamine, serotonin. We looked at the impact zones, prefrontal cortex, hippocampus, cerebellum, and the consequences, both immediate and the serious long-term risks like brain atrophy and dementia.
Complex picture.
Definitely. But we also ended on a note of hope, highlighting the brain's incredible capacity for recovery, for neuroplasticity, once alcohol is removed.
Indeed. And perhaps a thought to leave you with. Given how profoundly alcohol impacts these fundamental brain functions, judgment, memory, mood, coordination, what does exploring this teach us about the really delicate chemical balance within our own heads? And maybe how can understanding that delicate balance empower you, not just regarding alcohol, but maybe in thinking about stress, learning, or other aspects of your overall well-being?
That's a great question. Thinking about that internal balance is powerful. Understanding these systems definitely shifts perspective. We hope you'll reflect on that. Thanks for joining us on this deep dive, and we encourage you to continue your learning journey.